Okay, today we're going to work on lesson 511, explaining the equivalent fraction rule. So our objectives, we want to be able to relate multiplication rule for equivalent fractions to the effect of multiplying by 1, and apply and extend previous understandings of multiplication division to multiply and divide fractions. So let's list three equivalent fractions for 1/4. Okay, so you remember what we worked on before. To find an equivalent fraction, all you have to do is multiply the numerator, the denominator by the same number. So I'm going to multiply them both by 2. So I know 1 times 2 is 2. 2 times 4 is 8. And then I could take these same fractions, multiply them by 2, and I would get 4/16, which would still be equivalent to 1/4. I could go back to 1/4 and multiply them both by 3 and get 3/12. There's infinite possibilities. You just have to remember to multiply your numerator and your denominator by the same number. Okay. So you can pause the video and go ahead and write a few of those out there. Same thing, you're going to multiply the numerator and denominator by the same number. Okay. And then the level 3 one here, 3/7, same thing. You're just multiplying the numerator and denominator by the same number. So if that's 2, 3, 4, the only one you wouldn't want to use is 0 and 1, because it'll give you the exact same thing. So just to review the equivalent fractions rule, a rule stating that if the numerator and denominator of a fraction are each multiplied or divided by the same non-zero number, the result is a fraction equivalent to the original fraction. And the multiplicative identity is the number 1. The multiplicative identity is the number that, when multiplied by any other number, is that of any other number. So any number multiplied by 1 is the number that you're multiplying 1 by. So go ahead and open your math journal, and you're going to complete problem 1 on page 184. So go ahead and pause the video now, complete that. After you complete that, problem 1, come back. Okay, so what do you notice about the number sentence in problem 1? Something we want you to think about there. And who wants to explain their answer? A little bit harder to do at home, but let's go ahead and look here at problem 1. So remember, this one here is greater than, then you have less than, equal to. So 5 halves, I know it's going to be less than 5 because a half is less than 1. So I know 5 times 1 is equivalent to 5, but 5 times a half, or I also know that half of 5 is 2.5. When I look at this one here, it says 5 times 87 is less than 5. That seems like, because again, multiplication, that it shouldn't be right. But if you look at 86/7, it's less than 1 whole. So the multiplicative identity says 5 multiplied by 1 would be 5. So in this case, 86/7 is a little bit less than 1 whole. Okay, this one we can see that our fraction is greater than 1. So we know that 5 times anything greater than 1 is going to be greater than 5. In this case, the multiplicative identity comes in there, and you can see 5 times 1 is equal to 5. This one, 5/4, I know is greater than 1, so it's going to be greater than 5 when you multiply. So don't always assume that your number is getting larger when you multiply. If it's a fraction less than 1, your number will actually get smaller. Okay? And so like it says here, 5 times a half is less than 5 because 5 times a half is the same as half times 5, and half of 5 is less than 5. 5 times 2 1/3 is greater than 5 because 5 and 2 1/3 is like 5 groups with 2 1/3 in each group. Just thinking of 5 groups of 2 gives 10 things, so the total with 2 1/3 will be even more than that. Then 5 times 5/4 is greater than 5 because 5/4 is greater than 1. We talked about. And then 5 times 87 is less than 5 because 86/7 of 5 is only part of it, right? It's not 1. Okay, so in general, how do you know whether each product was greater or less than 5? Okay, so the rule that I follow is just a multiplicative identity. If it's 1, if you're multiplying the number times 1 or greater, then it's going to be great. If you multiply it by something greater than 1, your product's going to be greater. If it's less than 1, we know it's going to be less than. So let's look at these ones and see if we can figure out what we could do here. When I look at this, I see 2/3 times 1, which is just simply 2/3. 6,789 times 1 is simply 6,789. What is 12 times 1? It's 12. So again, examples of the multiplicative identity. Any number multiplied by 1 is simply itself. So how could you summarize the results of multiplying by any number by 1? When you multiply by 1, it stays the same or it stays itself. So the idea of multiplying any number by 1 does not change the value of the number. It's called the multiplicative identity property. So today we use this property to explain why the multiplicative rule for equivalent fractions works. So what would be some fraction names that would go in this name collection box? So when I think about it, I know when I write a fraction, any fraction that has the same numerator and denominator is going to be equivalent to 1. So again, infinite possibilities. I could do 100 hundredths. I could even do a billion billions if I wanted to. I could do 7 sevenths. So think about that on your own. What other numbers could you come up with? Again, it's infinite possibilities. What makes them equal to 1 is that the numerator and denominator are exactly the same. So what do you notice about fractions that are equivalent to 1? Well, hopefully you notice, like we just talked about, that the numerator and denominator are exactly the same value. So think about what you know about fractions and division. Why does it make sense that a fraction with the same numerator and denominator is equivalent to 1? So let's look at an example. So if I have 7 sevenths, right, I'm going to read as a division problem. 7 divided by 7 equals 1. And that would work with any number. Anytime you divide a number by itself, it is equivalent to 1. So you're going to explore the result of multiplying fractions by fractions equivalent to 1. So let's look at these and do some solving. So 2/3 times 4/4. Okay, to simplify it, I could simply just say 2/3 because I see that 4/4 is equal to 1. So in the end, in the simplest form, it would be 2/3. Now you could multiply across and get 8/12, and then you could simplify it. Again, same thing here. I see 5/5, so I know it's equal to 1 whole. So I could multiply across and say 15/20. Or because I know I'm multiplying 3/4 by a fraction of 1, I could just simply say 3/4. As we look at the next two here, let's see. Again, I see I have a fraction that's equal to 1. So I simply could write 5/6. And that would be in its simplest form that way. Again, here I see I have a fraction equal to 1 because the numerator and denominator are the same. I could multiply across and say 9/24, or I could simply just say it's equal to 3/8. So it's kind of cool to see that. Hopefully you notice that pattern there. It makes it a little bit easier when multiplying fractions when you're multiplying by a fraction equal to 1. So what do we notice about the second factor in each problem? That it was equal to 1, right? So we were able to use the multiplicative identity property to answer those problems. Now, what does this fraction here represent? So when I look at it, I see the dotted line separating it, and I see that it's split into thirds, and I see there's 1, 2 shaded, so it represents 2/3. Okay, so let's look at the fraction we have here. Let's look at my total pieces. I have 1, 2, 3, 4, 1, 2, 3. So I could do a 3/4, which is 12 total. So I have 12 pieces. Now I have 1, 2, 3, 4, 5, 6, 7, 8 shaded pieces. So 8/12 is what it represents. Or you could even, if you wanted to, divide both of them by 4 and get 2/3, which you can see the 2/3 here. Here's 1/3, 2/3, and then the third part is not shaded in. So the product is equivalent to the first factor. Now, the multiplicative identity property tells us that the product of any number and 1 is the number. When a number is multiplied by a fraction equivalent to 1, the product is equivalent to the number. Multiplying by a fraction equivalent to 1 is the same as multiplying by 1. Finding an equivalent fraction by multiplying the numerator and denominator by the same number is called the multiplication rule for equivalent fractions. So how does the multiplicative identity property help explain the multiplication rule for equivalent fractions? So think about that for a minute. So when I multiply by 5/5 or 7/7, that's still equivalent to a fraction equal to 1, right? So no matter what fraction, if the same numerator denominator is equivalent to 1. Okay, so go ahead and look at journal page 184. So go ahead and pause the video and complete those and then come back. Okay, so you should have already looked at problem 2 here, but let's go ahead and look at it. It says write 3 fractions that are equivalent to 1. So 3 fractions that are equal to 1. So yours may not be the same as mine, which is fine, but I have 2 halves, 5/5, and 10/10. So again, any fractions with the same numerator and denominator. Second part says use the fractions you wrote in part A to write 3 equivalent fractions to 4/5. So let's look at that. So you can see we chose to do 3/3 as an example here. And so 4 times 3 is 12, 5 times 3 is 15. And then we decided to do 2 halves, so 4 times 2 is 8, 5 times 2 is 10. 4 times 5 is 20, 5 times 5 is 20 25ths, and 40 50ths when you multiply by 10/10. And each of these are still equivalent to 4/5. It just gives you new names for those, right? So explain how you know that the fraction you found in part B is equivalent. So you should have already answered this. Let's look at our sample response here. I multiplied 4/5 by the same number in the numerator and in the denominator, which is like multiplying 4/5 by 1. Any number times 1 equals itself, so the product has to be equivalent to 4/5. And then here, if you haven't already completed this, go ahead and pause the video and complete that now. Okay, so look at the fractions in the table below. They all can be rewritten as equivalent fractions with a denominator of 12. What would you multiply each fraction by to make 12s? Write the fraction name for 1 that you would use in each case. Then find the equivalent fraction with a denominator of 12. One row has been completed for you. So our goal is to get to 12ths over here, a denominator of 12. Okay, so I have 4, so I know I would multiply that by 3/3, because 4 times 3 gives me 12, and the 3 times the 3 gives me 9. And so if you look at the next one, same thing. I look at the denominator. I know it tells me I have to have it out of 12ths, so I could say 6 times 2, so I would do 2 on the top, and 5 times 2 is 10. So you should have already completed this. I'll erase my writing so you can see a little bit clearer there. Okay, so you can see that again, the goal was to have your denominator out of 12. So they did 6/6 because it's 2 times 6. They did 2 halves, or 2 seconds because 6 times 2. And they did 3/3 because of 4 times 3. So pick one fraction name for number 1 that you use problem 3. How do you know the fraction is equivalent? So again, you're going to explain how you know. Okay, and then for extra practice, you can work on your Homelinks 511.